welcome to the 2026 TCT Women in 3D Printing Innovator Award finalist reveal. I'm Laura Griffiths, TCT Head of Content, and over the last few weeks, we have asked the additive manufacturing community to put forward the innovators for the Women in 3D Printing Award, and a panel of judges have painstakingly whittled those nominations down to the 5 nominees you'll be hearing from shortly. I'm happy to have Pooja Singh from Women in 3D Printing with me today. Welcome, Pooja.
Thank you so much, Laura. I'm so excited to be here.
Me too. And in case this is your first time joining us today, since 2019, TCT and Women in 3D Printing have worked together to really shine a spotlight on the women inventors, engineers, researchers, and advocates who are shaping the course of the 3D printing industry. And I say this every single year, but I'm always left feeling truly inspired by the people that this award places on our radar and the work that they're doing. So Pooja, for our viewers who maybe don't already know, who aren't familiar with Women in 3D Printing, can you tell us a bit about their mission and what this award means for the industry?
Absolutely. To briefly introduce myself, so I lead Women in 3D Printing under the umbrella of ASME, which is the American Society of Mechanical Engineers. It's truly an honor to introduce the Women in 3D Printing Innovator Award and the incredible finalists that you'll be hearing from later on today. Women in 3D Printing is a global community dedicated to advancing and supporting women across the additive manufacturing ecosystem, from engineers, researchers, founders, operators, educators, and we even have students. What started as a grassroots movement has grown into a truly international network with chapters across dozens of countries. At its core, Women in 3D Printing is about visibility, access, and belonging, creating spaces where women are not only truly participating in additive manufacturing, but shaping its future. Why this award is so important is because recognition matters. Too often, the contributions of women in additive manufacturing are under-recognized, even when their work is shaping technologies, companies, and industries. This award celebrates not just technical excellence, but leadership, creativity, and real-world impact, while also showing the next generation what's possible in additive manufacturing. I'm incredibly excited for you to hear from our 5 outstanding finalists and to learn more about their journeys and perspectives. Congratulations to all 5, and thank you so much for having me.
Thank you, Pooja, and happy to work with you again and work with Women in 3D Printing this year on this incredible award. And we're doing things a little bit differently this time around. Instead of our usual panel session, in a moment you'll hear from each of our 5 nominees through some short Q&A sessions. We tried to pack in as much as possible, but each of our conversations really only scratch the surface of what each of our finalists have contributed and achieved within the AM space. Once the broadcast has gone out today, the live vote will then be open, so it's over to you to then choose who your winner is for this year. So I think without further ado, let's meet this year's finalists. So hi, Joanna, welcome and congratulations on your nomination for the 2026 award. Happy to be chatting to you today.
Happy to be here. Thank you so much.
It's such a privilege to get to talk to you for the first time. And I think a question I always really like to launch into with anyone I'm meeting in the 3D printing industry for the first time, but particularly with this award, because we get such a range of different areas of expertise, is to ask our nominees, what was your kind of light bulb moment, entry moment? When did you first see 3D printing, or when did the technology first really have that kind of click moment with you?
Yeah, for me, it didn't click immediately. Like I saw 3D printing in college and I just thought it was kind of a toy. But then when I got to grad school, I joined Professor A.J. Boydson's group at University of Washington. And within the first and second year, I started building 3D printers to try and advance the chemistries of the 3D printing systems. And after building that first printer and then seeing the direct benefit on my chemistry, that was the real light bulb moment for me, when I could actually change the chemistry on my own, put it back in the printer, try again, and immediately see a change in properties. So that was really cool.
And I've definitely got questions that I want to get into a little bit later on with you about those specifics. But how did that sort of materialize into a career then for you? How did you sort of transition from doing this here to actually deciding, no, this is what I want to do with my career?
Yeah, it's just how tactile it is, how easy it is to see the impact on what you're doing in the real part and the benefit of geometry on the real part. All of that really is what made it into a career for me. Just that really instant feedback, that constant learning loop of here's what I'm doing, here's what I'm trying to do, and here's where I'm at. And for me, just having that puzzle always, all the time, that's why I love 3D printing, is this constant ability to change and adapt and evolve chemistries as we evolve these 3D printing systems.
So I feel like I already know kind of the answer to this next question then, but you specialize in volumetric AM, materials, chemistries in what you do, all the exciting things that you just briefed on then. But what are you most passionate about in 3D printing today? What as someone who works in this industry, what really gets you going? What gets you out of bed every morning, excited to return to work every day?
Yeah, really, it's pretty much the same answer. I don't want to keep harping, but I really love this ability to make new chemistries printable, to make new things printable, whether it's multi-material, composite materials. There's always, a target application in mind, but the ability to advance it and incorporate 3D geometry control into a new chemistry, that's so cool to me. It makes me feel like a wizard. I really love making something that was previously only accessible on a bulk scale on a lab bench, now accessible to a 3D printing system. That's what I really like.
Joanna, I imagine if you said those words to any young person wanting to get into the industry, it makes me feel like a wizard. You'd have no problem getting them to sign up right away.
It's a pretty cool feeling. There's certain different types of 3D printing and volumetric additive manufacturing. We're using things now like microwaves. You can't see microwaves. So I really feel like a wizard there, when you're zapping your material and it's changing to that. It's pretty cool. But yeah, I definitely feel like a wizard sometimes.
So as a polymer chemist, can you talk about some of those new materials possibilities in a little bit more detail in the limited time that we actually have today, and the possibilities that AM is enabling? Because I hear a lot about materials as this really enabling force in additive manufacturing, but can you perhaps give us some more insight into how that works, how those opportunities are maybe identified, how that development process is for you?
Yeah, definitely. And it's a really fun space to be in. It's a really open space. There's a lot of chemists in 3D printing, but really what it comes down to is changing the way we design the world around us. Mm-hmm. How do we identify a material? Really, it's kind of easy. Any material that you would want to manufacture in a broad sense is something that you might want to be able to utilize in 3D printing. And there's so many materials that we use in manufacturing all the time, epoxies, rubbers, silicones, adhesives, but maybe there's some benefit to 3D geometry that could be beneficial to the system. Any of those materials, if they're something we want to work with, if there's something we want to use in industry and manufacturing in the world, those are something that maybe we want to adapt to 3D printing. So for me personally, I have a really broad interest in multi-material printing, this idea of getting soft and hard, conductive, insulating, multiple properties from a single object at a single print process. And so that multi-material printing is something that I really want to push forward, this idea of if you had a rainbow of light, then you could have a rainbow of different materials all being fabricated at the same time.
And you talked then about some of the properties, but you mentioned something key early, which is that in these developments, there's always an application in mind. And that's something else that I wanted to ask you about, because the person who submitted your nomination talked about the multiple implications of your work and the different kind of fields that it taps into. So automation, they're using 3D printers as high throughput screening tools, and battery materials, just to name a few there. Can you talk about some of the specific applications or maybe the specific advantages that AM is opening up in those areas? Maybe some of those particular might not get as much attention as the ones that we see quite regularly in additive manufacturing.
Yeah, definitely. So at the same time that I'm always trying to advance the chemistries for 3D printing, we've also been developing multi-material printing techniques as tools for chemistry development, largely right now for energy applications, but really it's a tool system. So I call it studying polymers on a chip, or SPOC, to make materials that live long and prosper, which is my classic Star Trek joke.
Gotta get that in there.
But the idea is that we have these advanced multi-material mixing capabilities in direct inkwrite printers where we can handle really disparate viscosities, anything from water all the way to a million centipoise, like window putty, large, shortening. So if you can access now materials in all of these viscosity ranges and modify composition in real time, you can then also incorporate things like characterization, so you can measure the properties you care about for that end application, and then optimize those properties first before you ever get to a 3D printer. And for me, that's really nice, because my job normally is to try to print something, find out it doesn't work for the application I'm targeting, and have to reformulate and do that process over and over again. So we're trying to accelerate that optimization loop for targeted applications. Anything we can measure is now something we could optimize. And so currently our team is working on a number of different applications, including polymer electrolytes for battery applications, anion exchange membranes for water electrolysis and fuel cells, increasing their alkaline stability, as well as improving the mechanical properties of engineering polymers for 3D printing specifically. So that's not any limitation in the tool of SPOC to target other applications. It's just, what do we want to target first and what do we want to optimize? And so that's what's really exciting about that.
Yeah, it sounds like there's lots of different opportunities and lots of things that you're working on right now. Very exciting stuff happening. But one question I do want to end on today, and I can't help but always ask about the challenges in the additive manufacturing industry. But as a scientist specializing in AM today, and with your particular areas of expertise, is there maybe something you would highlight as what is the biggest challenge right now, maybe the biggest challenge that you're currently working to solve?
Yeah, I really think that challenge is the integration of all things, which it's a really interdisciplinary problem. But in order to be in 3D printing and have it be relevant for industry, relevant for targeted applications, there's got to be geometry control, materials optimization, industry understanding, target end analysis, lifetime, right? And so all of these different pieces generally are different people. And so what's most exciting about 3D printing is how integrating it is to all of these different components and bringing all these people together on the same research. And so it's simultaneously the problem, but it's also the fun part of it. Obviously, again, I think multi-material control is going to be really, really important for the future. We don't want monolithic things. We want to be able to take anything we want and put it wherever we want it. And that's really going to step up 3D printing, additive manufacturing to the next level, I think. So yeah, that's my 2 cents.
Thank you so much, Joanna. It's been absolutely great just to get to know you a little bit today. And good luck with the nominations for this year's award.
Thank you so much. And thank you for the interview. Really happy to be here. And yeah, fingers crossed. Thank you.
Hello, Sharon. Welcome and congratulations on your nomination for this year's TCT Women in 3D Printing Innovator Award.
Yes, thank you.
It's so nice to chat to you today and find out a little bit more about your work. But the first place I always like to start and to ask our nominees is to find out a little bit about what your light bulb moment was with 3D printing, perhaps when you first saw the technology or when it first really clicked as something for you.
Yeah, I think before I share about my light bulb moment, maybe a bit more about myself. So hi, everyone. I'm Sharon Nai from Singapore, Additive Innovation Center here at A-Star. So I have my background in mechanical engineering, where I specialize in materials. So during my master's and PhD days, I mainly work on materials like lightweight metals, magnesium and alloys, but using more of casting as one of the means to make such structural components that's lightweighting. But in 2013, right, I had the opportunity when I joined A-Star years before that, right? And in 2013, I became part of the pioneering team in Singapore that had the opportunity to secure this competitive grant, right, to establish additive manufacturing capabilities in Singapore for industries. So it was actually very exciting for me, and that was actually the start of my journey, right, in additive manufacturing. So my light bulb moment came for me when I had the opportunity to see a laser powder bed printing happening, right? So when I see that the metal parts is being made layer upon layer, I realized that, you know, those very complex, intricate internal features, right, couldn't be actually achieved by what I traditionally known that cannot be done, especially using machining or even casting. So it was at that moment for the first time that I can then clearly see that how we can actually achieve, right, the synergy between materials and processes coming together to achieve not just lightweighting, but also improve functionality and performance, right, all into one part. So I think that has been the light bulb moment for me from then on. And I remember holding the part and thinking that this really changes what I know about manufacturing. So, and then I think from then on, I do see a lot of opportunities that's coming together, the convergence of materials, design together with processes, all integrated into one approach through additive manufacturing.
Mm-hmm. Well, so when did that moment then, when you first saw these lasers on the powder bed, how did that go from then to where you are now as director of the centre? Can you talk a little bit about that journey and what's happened in the time since?
Yeah, I think since that light bulb moment, I think it's definitely, as you mentioned, it is a journey, right? It is not just a single turning point for me. So I have over the years, right, as a researcher at A-Star, to have opportunities to work closely with industry partners that then allow me to really realize the importance, right, how for any manufacturing technology solutions to succeed, which also include additive manufacturing, the technology itself cannot exist in isolation. So partnerships, right, is actually very important. Connected ecosystems around it is also very important. So this is where, through my years, right, having earlier years working on R&D related work is very hands-on. So I focus more on developing the technology solution, building additive manufacturing capabilities from ground up through R&D, new materials innovations down to process development, and also infrastructure setup. And of course, also learning what it truly takes to move it from lab scales all the way to what industry can then rely on. So that transition phase itself or the journey actually taught me a lot about innovations and also what it takes, right, to bring it into the industry. So it has been a journey over the last 12 years, I would say. And together, I think as the technology mature, my role also evolved, right, towards now building more long-term partnerships with my industry and also research partners that I have developed locally and internationally. And I'm also deeply involved in establishing industry joint laboratories, or we call it joint labs here, right, with key partners. So how through all these commonality of putting together platform solutions for companies, researchers and engineers can then work together, right, to look at common manufacturing challenges that they face relating to additive, right? And such coming together, especially with the additive innovation centers that I'm leading, right, it's also a place that goes beyond just being an R&D place, right? It's also a location where they can come together to build relationships, to co-create. And of course, importantly, it's a place where we can also develop the talent pool as well.
Mm-hmm. You talked about a lot of important things there, the collaboration, the talent pool, but really working together. So I'm wondering what is it that you're most passionate about in 3D printing today?
It's really seeing the potential of it being realized, right? Not just coming from design, right? Now we are able to actually making actual parts, right? Having them being deployed as well. So it is no longer just confined to that producing parts faster or having more complex components. I think now we have moved into also the next phase whereby components now are able to be smarter, more functional. The use of sustainable materials also give advantage to this as well. So I think every day I'm motivated by such opportunities to explore new materials, new processes, and also design possibilities, right, for products that and also bring them together in ways that can create industry impact for our partners. And of course, I think the other part is also opportunities to work with industry partners that come across different sectors, right? So some of them come from aerospace. We have partners from maritime, healthcare, and also the semiconductor industries. And each of these sectors comes with their own set of unique challenges, right? Yeah, because different material system, different environments that they are being exposed to. So by collaborating with them allows me to constantly push myself as well to think differently about how additive manufacturing can be applied in various ways to actually meet their needs, to serve them. Right, so I'm motivated coming from that aspect to be part of this whole ecosystem where our partners, our collaborators from research, and of course, importantly, is also the AM community that we have, right? And my team here as well in Additive Innovation Center at A-Star. So understanding that innovation itself does not happen in isolations. So the importance of people coming together, sharing their knowledge, their ideas and experience is something that I see the value, right? And I think over the years, through the joint lab partnerships that I have together with the team developed, right, also see a lot of these opportunities and also experience being developed over time. I think the other aspects of it is also going to the last mile with our industry partners. So we have the pilot productions that we champion here at the Additive Innovation Center. That part itself, to me, is very rewarding because it helps to realize deployment all the way to the last mile for the industry. So it's no longer just about having materials innovations or process innovations, but it's actually demonstrating a part beyond just in the lab, but having the means to validate processes, de-risk adoptions, right? And then ensuring that companies is able to scale with the technology. So that part has been very fulfilling to translate the science into industry impact.
And I think you play such an important role really within that ecosystem in being this kind of touch point between industry and academia there, and having taken this from research to real world applications. And your nominator for this award really credited your pioneering work in the binder jetting of reactive biodegradable magnesium from powder to finished parts. So that was just one of the examples that was spoken about. Can you maybe give an example or tell us about how the impact that work could have really on real world applications?
Yeah, so magnesium, it is a promising materials, right, that has been used for biodegradable implants. And we chose that is also because it is able to dissolve in the body, right, without us having to go for secondary surgeries. But this choice of material itself is also highly reactive, right, and therefore extremely challenging to process, which includes having to process them using additive manufacturing is also pose a challenge. Especially initially, I actually wanted to explore, right, using the laser powder bed technology, but because of the laser heat source, right, that gives rise to some other concerns. So it then motivates my team here at A-Star together to actually go about developing a binder jetting technology instead, right? So we took on this challenge and developed a full end-to-end digital workflow for the producing of patient-specific implants using this technology of binder jetting, where we also introduce or develop a novel in situ binding mechanism itself to allow us to leverage on surface chemistry of the magnesium powders to form temporary bridges during printing, but they will decompose during the sintering process. So these innovations actually allow us to produce parts with tunable mechanical properties. So they allow us to have a range of porosity levels that is comparable to that of human bones. And also I can tune the porosity level all the way to minimal porosity to reach fully dense parts as well. So with these advancements that we have developed, it allows us to then have the opportunity to scale them as well. And also we studied some of the challenges like shrinkage predictions, control of distortions, down to how do we have better support structure strategies for the binder jetting technique. So I think over the years, we have definitely advanced with this, right? So actually this work itself is also a journey. So we began in 2015, right? And it's done through collaborations that I had with the National University of Singapore, through a co-supervision of students, that PhD students that we have, right? Who later on joined my team at A-Star to further advance this technology. So over the years, in the more recent ones, right, we have actually integrated beyond just the printing process itself, but came out with also the end-to-end solutions that includes the hybrid additive and subtractive workflow integrated inside. So we incorporated the automated machining, 5-axis machining portion as well, so that it will then enable us to fabricate very complex structures as well. Right, so I think with that, with years of persistence and also innovations and teamwork, we were successfully recognized internationally last year in 2025 with award from Magnesium Science and Technology for Innovation Process of the Year. So I think this is evidence as to how we have, through this piece of work, right, advanced not just the understanding of using magnesium, right, but also demonstrate the effectiveness or the potential of additive manufacturing, for this case, binder jetting, translating the fundamental research into scalable industrial solutions. So this then brings us closer to realize, right, the next generation of biodegradable implants, and also moving towards having lightweight magnesium components in the near future.
Mm-hmm. Sharon, I'm sure I could do a whole interview of you just talking about that very application there. But I've got one more question left for you that I'm asking all of our nominees this year, and it is: what are the biggest AM challenges that you're working on right now, or what is perhaps your biggest challenge today?
I think the biggest challenge is, therefore, my focus and my commitment is working towards industrializing additive manufacturing at scale, right? And of course, with impact, right? So we have seen additive manufacturing producing high performance parts for industries that are highly regulated, like aerospace, healthcare, right? And even down to outside, a lot is in the semiconductor industries, right? For complex machineries and components in those sectors. So moving them beyond just pilots runs, right, but into production has remained difficult. So I think it's not just about the technical challenges that we are looking at closing, but the industrializations aspects of it is also requiring a very complete end-to-end ecosystem. So it's not about just having the right printers, right, the right printing solutions, but it's also involves like materials innovations, having the right post-processing capabilities as well, all the way down to digital workflows, standards, and also organizational processes. All these have to come together seamlessly in order for the success to happen. I think the other aspects of it is also the people readiness level is also very important. So we do see that the workforce need for actually mindset shift, right, from traditional manufacturing mindsets into designing, qualifying, and also operating, right, with additive manufacturing in a very integrative way is important, right? So we do see the need for us to also align, right, the users of this technology and also technology developers like myself and my team, right? So users might understand industry production constraints and business needs, but the technology developers like ourselves will be pushing the advances in hardware, software, and materials, for instance. So it's very important for us to work together, because without the close collaborations, either we will ended up having a great technology that lacks applications, or we will have a strong demand that the existing technology can yet achieve. So it is balancing, I think, these two aspects of it for them to come together. So yeah, that's where I see that there's a lot of opportunities, and this is what excites me, is that the challenges are interconnected, where the technology, the people, and the partners, right, have to be aligned into a coherent ecosystems, right? So these are some of the commitment and focus that I'm helping the industries to cross the gap from innovations to industrial impact.
So hello, Jill. Congratulations on your nomination for this year's TCT Women in 3D Printing Innovator Award.
Thank you. Thank you very much. I am so pleased to be nominated, and I think we have a good story to tell here.
Yeah, we're so happy to have you here on this year's cohort. And before we do launch the vote, we always like to chat to each of our nominees, really to get to know you all a little bit better and talk about the work that you do. So in the short 10 minutes, I know we're going to try and cram things in here, because I know you've got an awful lot of exciting things going on. But to start, I always like to ask our nominees, what was the light bulb moment with 3D printing? When did you first see it? When did it first really click with you? What do you remember of that initial interaction with 3D printing?
I had my aha moment when I was doing my master's, and it was love at first sight. It really, really was. I do enjoy the creative process, and I get involved in a variety of design projects. And so the idea of going from thought to thing and being able to do it quickly and do a little bit of a test and tune and then adjust, it's just absolutely delightful. And I have a part that I want to show that one of my master's students did.
Yeah.
And this is a mannequin for thoracentesis. And many of the mannequins that are available to medical practitioners are flat, and they have different rib spacing, obviously, than when you're a child and when you're an adult. But about 20% of thoracentesis is when they have a needle and they take fluid out of your lungs, right? So I don't know about you, but my rib cage is curved, and so having a flat training mannequin right there is a little problematic. But about 20% of the operations are between children that are just born to adolescence. There's a tremendous amount of growth period that goes along there. So how could we create a solution that would enable medical practitioners to be able to do a test and tune, for a girl who's 8 years old or for a boy who's 12? And so that's what I'm showing here, that we actually designed the mold set as well as the rib cage, the clavicle, and the scapula. And you really can't see, I think, in the camera, maybe we can, but you can see that there's different colors on the outside and the inside. So we actually worked with our Schulich School of Medicine and Dentistry. We did some cadaveric testing to determine the characteristics of skin and muscle and fat. And then we designed the molds. We designed a parametric solution. So you just type in the age and the gender, and the molds and the rib cage, everything is all scaled appropriately. Wow. And then we can build it. This guy had zero manufacturing experience, and this was his master's. It's a stunning piece of work.
Wow.
And, so my aha moment really was pivotal, because it excites me to be able to come up with these solutions that they're not just typical engineering solutions. They're everywhere.
Yeah. I mean, it sounds like, you talked about it being love at first sight there, having this real aha moment. How did that then turn into a career moment for you? How did you then sort of think, okay, this is what I want to be in, this is what I want to do?
Like I said, I enjoy the creative process and design and build. So my research focus is in advanced manufacturing. And so we have to take a little step back. All right. And so when we're machining, we design a part, and then we go into the software. Yeah, lots of options, right? But then, okay, this is the operation that I want. This is the tool path. And there's a lot of fiddling that goes on. But when we're done, and after we do our simulations, we go, I need to change things. Well, then with a single click, after I change the design, the changes are propagated into the build solution. And I can simulate that build solution. And this didn't exist for the plastic systems, right? You do your CAD over here, and then you STL it, and then you go over here, you build, I don't like it, then I go back. And we need a unified pipeline similar to machining. And one of the things that we do not talk about enough is post-processing. Anybody that's built a part knows, you got to trim the supports, you got to sand, you need a little of this, a little of that. Well, we ought to be able to design the part, model the additive process, get an idea what the beads look like, have an idea of the characteristics of the voids and all that other good stuff, right? And then if we need to tweak the design, add a little stock, for example, and then do some machining, we ought to be able to do it in the same software package. And this is the foundation of the research and the foundation of some of the activities with the company my husband and I co-founded, Manufacturing Solutions, Inc.
I want to talk to you about Manufacturing Solutions, actually, because you come at this from such a unique point of view, really. Sometimes we've got people that are based in academia and research, and then you've got the business side of things. But I really want to ask you about this as the founder of a business that supports the advanced manufacturing sector, but also as a professor in the academia world. How does being industry facing with manufacturing really influence the kind of skills that you prioritize in teaching at the advanced production and design lab? Because we do often hear about this kind of disconnect between industry and the education side of things.
That's a wonderful question. And the key thing that I would like to project to people is that I had industrial experience before I came back to school. And when we solving a problem, we have to look at things from multiple perspectives, multiple disciplines, and multiple perspectives is always very, very important. And so we can't manage what we don't understand. It's really fundamental, right? And in industry, we expect a very high level of performance. And experimental is just a sexy way of saying unreliable. It is. And the reality is we expect things to run and run well. I don't know about you, but during COVID, our car sat in the driveway for quite a while, right? And after a few months, you put the key in, or push the button, whatever type of car you have, boom, it goes.
Yeah.
The tires were a little flat, but after we were driving, and you don't even think about things like this, right? Our expectations are high. And they're high because there is some real science that has gone into the casting, the forging, the machining, all the other classical manufacturing processes. And we have a pipeline of talent. We have the skilled trades, we have the sophisticated users and designers and management. We don't have any of that for the additive domain. It came from universities, right? And so we've got to propagate this down. And the key thing, there's two parts to the challenge. And one is creating the knowledge. And this is the fundamental research. And I'm working with some excellent colleagues. Dr. Altenhoff is a crash testing expert, and Dr. Alpas is doing wear testing. So we build a part, it's a metal part, and we put it in a crash scenario. Will it perform the same? We need to know that, right? And so this is the research. And this is what we need academia for, because they have the equipment and they can do the detailed analysis. But then we have to translate that into design rules. We have to translate that into software. We have to translate that into knowledge that people can effectively use. And that truly is one of the challenges, is bridging this knowledge pipeline. I'm mixing metaphors here, but we have to create the knowledge so that we have the same confidence level, because I look at additive manufacturing as another tool in the manufacturing toolbox, right? Yeah. But then we've got to propagate that knowledge. And working with people in industry, these are their problems. Okay, that's great. That helps us. This is what we focus on in the research domain. But then once we get answers, how do we inform people? And the key thing is, we need to create that talent pipeline, and we need to create that talent pipeline for people who are just generally interested. Anybody can go and get a drill press and start drilling, right? Everybody knows somebody that has a printer, somewhere in the house, right? But what's the best way to design the part? What are the design rules that we should use to make, because we know the properties aren't uniform. We know that the strength is different in different directions, right? So should we thicken things? Should we modify things a little bit? Well, we don't know that yet. We need to get that out there. And so you have to look at it from a user point of view. Very important. And the user ought to be able to achieve the performance that they expect. But then we have to go back into the academic levels to figure out what are the driving mechanisms that lead to failure or lead to better performance. I'm completely convinced we can do things with additive processes that we just can't do with any other manufacturing solution that's out there right now. And we need to be able to exploit this effectively.
I feel like you've kind of touched on it there already, but I wanted to ask this next question just because I wanted to make sure I get across some of the really nice things that were said about you in your nomination process. So the person that nominated you talked at length about the impact of your teaching, and you can feel that passion now just speaking to you today, from developing an online training course to spearheading this advanced production and design lab at the University of Windsor, just all these things that you've been doing. I could say, I guess you kind of touched on it then when you talked about how we don't really have a lot of these existing things for additive manufacturing specifically, but why do you believe it's so key that those skills are being really fostered today?
Well, we're building machines. We have software. How do we use it? It's really basic. We don't know. You get training on how to navigate a software interface. Okay, this is how you create a file. This is how you save it. But then what is the best way to build a part? And then it goes beyond that. How do we design the part? Design for manufacturing is something that we do teach our students, and this is something that is quite widespread in the skilled trades or sophisticated users environment, because they're just things that when you're building a casting, your mold has an angle to it, right? Because you need to be able to pull the part out, right? You do something like this, you never be able to pull the part out. Yeah. I mean, I know that's being kind of ridiculous, but the point is we have design rules, and those design rules complement the characteristics of the process. We need to be able to do that in the additive space. And the only way we can do this is as we learn, we need to teach. And one of the things that we just push a button. It's like Star Trek, right? Isn't this wonderful?
Yeah.
And you get an answer. All right. We need to look at things comprehensively. And you have unique health and safety issues. You've got unique pre-processing and post-processing. We cannot speak about that enough because there's a tremendous amount of cost associated with that. You get a system that is absolutely wonderful, and then, you need a sintering oven. You need to be able to machine for final finishing. And we have this additive process, but people aren't interested in just processes. They're interested in solutions. And this is where the teaching and the training is so important, because we have to understand the characteristics of our processes. We need to understand their advantages, and we need to understand their disadvantages so we can manage them effectively, because it all comes down to value and cost. So you need to understand the skills that are required, the infrastructure, the footprint on the plant floor in an office environment. What are the materials? Are there any special materials and health and safety issues, right? This is all part of the comprehensive model that you need to consider. It's not just a machine.
Yeah.
And the bottom line is, the only way that we can convey this information is as we acquire the knowledge. We need to teach it. We need to get it out there.
Jill, I could talk to you for such a long time now, but I've got one more question for you. As an AM-focused educator working in the additive space right now, what would you say your biggest challenge is today?
I just wish I had more money and people, because there's an ocean of knowledge that we need to understand. And I'm playing in a puddle. But really, again, we're right back to quality and performance and effectiveness and of the solution. And there's just so much that we need to learn. And we need to have a framework that integrates things from the systems level, from the management level, all the way down to the microstructure. Microstructure, ooh, that's a scary word, right? You know, you have a bunch of scientists looking under a microscope and looking at what things, but when we understand the details, then we understand how those details propagate up, and then the design and build decisions, again, everything is interrelated. So there's two real challenges, right? And again, it's all back to getting the knowledge and communicating that knowledge. And we need to have the skills of the people. Absolutely right. But that means we need to have the resources to be able to create that skill set. So it all comes down to the same thing, you know, time and money.
Great. Well, Jill, thank you so much for chatting to me today. It's been great to get to know you a little bit. And once again, congratulations on your nomination. Congratulations on your nomination for this year's Women in 3D Printing Innovator Award.
Thank you so much. Thanks for the opportunity to speak as well.
I'm looking forward to speaking to you today. I know we've only got 10 minutes, but we're going to try and cram in as much as we possibly can. But the first place I always like to start with our nominees for this award is to really get an understanding of what your kind of light bulb moment was with 3D printing when you first kind of either saw it or really saw the potential for this technology.
Yes, the light bulb moment for me really was the start of the COVID. So I remember this was in the beginning of 2019, and it was also the last business trip that I had to the Netherlands. We were faced with having an asset in Nigeria that needed a part, large glass reinforced polymer cover for a floating mooring buoy, and the part was obsolete. We literally had an engineer take that cover, which is over a meter, put it on a piece of paper and trace the outline, took a snapshot and sent it to me. He told me he needed this. The alternative was a 16-week wait to replace the entire top sign.
Wow.
So we got on the phone, we trained a local vendor, we got it scanned. The data was sent to us in the Netherlands. We reverse engineer, manufacture it, and it was packed and box ready to be shipped. All that work within 2 weeks and at a 90% cost saving. And I asked myself, why aren't we using more of this for obsolete parts across our assets?
Wow. I mean, I love that that is a real world application that sparked it for you. And can you tell me a little bit about how that is transformed into your career today and being an advocate for additive manufacturing? What was sort of the journey from that moment when you said, okay, why aren't we using this for more obsolete parts to where you are now?
Yeah, so essentially, in 2019, I was still actually working as a digital supply chain manager. And when the role opened up as a full-time additive manufacturing technology lead in the company in 2021, I decided to focus full-time on the role. I guess it was the mechanical engineering nerd in me that sort of pulled me to that exciting job. And over the course of the time, I have focused a lot on trying to create awareness of the application scope and to grow the scope as well in its use for various product or material equipments that are used in the energy sector. Now that I have formally offboarded from the company at the end of last year, I'm continuing to be an advocate for the technology. I have started a additive manufacturing and digital supply chain consultancy company of my own. I'm also volunteering in various organizations in the hope to continue to create awareness on additive manufacturing, volunteering in the IOGP, the International Oil and Gas Producer Association, as well as being part of the scientific committee in various organizations so that I can still use the knowledge and skill that I have built over 25 years in Shell to grow the application.
Well, I mean, just from hearing all of that, though, your passion is very, very clear for this technology. So my next question is, what really fuels that passion? What's keeping you invested in this technology every day? What's getting you out of bed in the morning and excited to meet with people and really push this technology forward?
I think the key was being able to use a technology that reduce the waste in terms of the material we use. I think that really helps with the sustainability of precious material and resources that we have on Earth. The other aspect is what I think is important, which is using a technology to create products, creating innovative design in products that we are used to. We didn't have the opportunity in the past, but with additive, I think it creates new types of product, and I am hoping that it opens up the possibility to create new jobs for the new generation as well. As a mother of 3 teenagers, I'm deeply concerned and would like to spend the time and resources I have to grow the application, grow the ecosystem, and through that, create jobs for the next generation.
I wonder if any of your children are showing an interest in additive manufacturing yet.
Oh, yes. Oh, yes. My youngest has already started to 3D print at home, so.
So I want to talk to you about your nomination for this award, because the person who nominated you spoke at length about all of the contributions you've made to the industry, but spoke about your pioneering work in the 3D printing of valves in oil and gas as a real kind of key component in establishing those very first industry specifications for this sector. So I wondered if you can talk about how that work has maybe evolved into different kinds of applications today, how that's really propelled the technology's adoption.
So it started, I think, us giving ourselves the challenge. Can we use additive manufacturing to produce a gate valve, which is a pressure vessel, a pressure containing component, sorry. And so it started with us challenging ourselves on whether we could use additive manufacturing to produce a gate valve, which is a pressure containing part. And actually not just producing it to meet the performance requirement to put it out in the field for application, but actually meeting as well on top of that, the regulatory requirement, which is the Pressure Equipment Directive in EU. We succeeded. The next question was are we able to expand that knowledge and make different types of valve, which we then went on to embark on manufacturing a ball valve, and that we succeeded and proven as well. Now, I realized the next step is the technology is mature for the type of application we need, even if it's at the moment still very narrow, but the knowledge and the specification is what we need to focus on if we want to start to mass produce it, which is why I've started to create the level of advocacy and working with the IOGP organization, the International Oil and Gas Producer Association, to form the first ever additive manufacturing expert group within that platform in order to bring the experts from the various energy and oilfield service provider company to contribute in knowledge and experience and start to draft what we will be issuing as the industry specification for how we are going to manufacture products that will meet the requirement of the energy sector. And one of the documents is actually an overlay to API 60, focusing on how we would use additive manufacturing to manufacture valve. And I'm quite excited that It's then available free for everyone to download to really start their own journey of how to leverage this technology in their product development for the energy customer.
I think that's quite a nice way to segue into this next question that I had. If you're meeting with industry and establishing this right now, because Angeline, when you and I last spoke back in 2022, you talked about how these early use cases really provided that much needed knowledge and data to really improve the sector's trust in additive manufacturing. How are you finding that trust level has changed since then?
Certainly, I think in terms of growth of acceptance and the level of knowledge, there is still a lot of work to do.
Mm-hmm.
There are today still engineers out that needs to learn more about what the technology can do and the associated standards. The application has certainly grown. We have, if you look at 5 years ago, there was no additive manufactured pressure vessel, pressure containing parts that has been approved and field deployed, but we do have that now. We're looking actively to, through providing industry specification and guidelines on how to use it in the energy sector, start to grow also the variety of parts that can be made, but start to also grow the volume. And I think this is still needed in order to really make a significant change, transformation into the new ways of working, which is not to buy and keep inventory in the warehouse, but only make them when needed.
And I know this has been a bit of a whirlwind tour throughout your career in the last 10 minutes, but I do want to ask each of our nominees this year the same question to finish on. You talked about trust then being a challenge and you know, the acceptance in industry, but what is the biggest challenge that you're working on right now?
I would say it's still in knowledge across the industry. And the knowledge on how to adapt their process to use and leverage the technology efficiently. So a change transformation is what is needed. That comes through in levels of the available standards and specifications that is ready to use, but also the change in the process of how a company will adapt its supply chain processes, as well as the commercial contracts and processes as well, in order to use it effectively.
Well, Angeline, thank you so much. It's been great to talk to you today. Congratulations again on your nomination for this year.
Thank you.
So first of all, congratulations on your nomination for this year's award.
Oh, thank you. I'm so happy about it. I mean, I'm just thankful about it. Yeah, I don't know what's gonna happen, but anyway, I'm just so happy about it.
Very exciting, and I'm excited to talk to you now. I know we've not got an awful lot of time, but we really just want to use this opportunity to introduce you to the audience before we kick off the voting process today. So somewhere I always like to start, and I always like to ask our finalists, is to really find out what your sort of entry point with this technology was. What was your light bulb moment with 3D printing when you either first saw it or first really took an interest in it?
Well, honestly, it started since college, like pretty early in college. My second job over there, it was at a 3D printing lab. Then I grew to like I went to like a bigger 3D printing lab that they did more research. And you know, I've always like stuck in that area, and it's because I love it, right? Like it's something that you can do like from a hobby level all the way to like industry and research. And it's just a fun technology.
And that's a pretty similar thing that we're hearing from a lot of people on this, you know, like you just can't, it doesn't lose the fact that it is just still a really fun technology to get to work with. So how did that turn into this career for you then, and where you're at today?
Well, yeah, as I mentioned, I kind of started in college, right? And when I was doing my internships, I did voice that I really love 3D printing,
Mhm.
right? And that that did take me somewhere because like one of the positions, I mean I had the opportunity of, you know, I was able to pick between like a couple options, but
Mhm.
because I did voice my interest, I got the position where I'm in right now, which is specifically, designed for additive. So like I don't know, I'm so happy. It's such a niche area, and I'm
Mm.
so lucky that I was able to get into it like right out of college. Um, so yeah, I'm still here and I love it.
So what keeps you here then? What are you most passionate about in 3D printing today? What gets you excited about returning to work every day in this sector?
hmm Yeah, I mean, we're always given such new challenges. I think, as we mentioned, 3D printing is so fun, and the design aspect of it, which is what I do, it is so fun,
Hmm.
and we're always given such new challenges, and because additive can really grow into like many different like avenues.
Hmm.
We can like we get a lot of different challenges, and
Mm.
because of that we get to push the limits on the technology on both what can be printed and what can be designed as well. So it never becomes monotonous, it's always exciting.
So the person who nominated you for this award, I always don't know whether people are going to get embarrassed by this when we start really, talking about your accomplishments. But the person who nominated you talked about how your work has really contributed to some critical milestones in your work today. So
Hmm.
including collaborating on an innovative nozzle fixture designs for advanced technology programs. I wondered what you can tell us about either that specific application today or any other application examples that you're excited to talk about that you're perhaps working on.
Yeah. Oh, well, that's nice. Yeah, I love the fact that I have not been tied to one product. Like, for
Mm.
example, what they mentioned on the fixtures, I've been actually last year, I did a lot of work on like several fixtures. It's, the coatings teams, they want to try new different things to improve their process. So they
Hmm.
need some specialized tooling for that, that fits whatever they need and something that they can iterate quickly. They try it out. It's like, we want to change something. So
Hmm.
we iterate, right? But I think the project I've worked for the longest, like different variations of it, it's a lot of acoustic work.
Mm.
Um, so we get to work with a lot of these like crazy geometries that we put
Mm.
on like different areas in the engine. But I mean, aside from that, I mean, and that is the one of those projects that has helped us, push what we can design, what we can print, how thin we can go.
Hmm.
Um, and just with additive, we do, a lot of topology optimization, thermal management and things like that. But I think those two that I mentioned,
Hmm.
those are really exciting ones.
I can imagine the more that you do and the more that you're really pushing this technology, the more it's opening up new opportunities and new ideas, across the business as well as people see the kind of how transformative it can be for some of those applications.
Yeah, no, it is. It is. It's just gives a new tool, and it's just a new avenue for solutions that people like sometimes like have never thought before if they're not like really involved in additive.
Hmm. And something I wanted to ask your opinion on, Andre, there's a lot of talk in additive manufacturing about using it to really reshore manufacturing, secure and strengthen supply chains, and particularly in industries that you're operating in industries that Honeywell operates in. And sometimes, within the additive manufacturing bubble that we live in, we hear about additive being a really big part of that. But I wondered if, in your experience, can you tell us maybe how significant is AM in making those shifts a reality?
Okay. Well, I think I can answer this from the perspective of a designer, which I am, right? And I see how like the projects, like several of the projects that come to us, I see how big of a tool it is for when parts are needed quickly, or where they are having issues procuring parts from suppliers, or whether they're outside or even like within, right? Because we have our facilities like in Honeywell, so that's also like a big help. So, and also, like aerospace, it's more of a low volume environment. So additive can be more helpful in that situation. And I have seen how big of a tool it is when you need to procure parts and you're having issues with it. So I do see how it is a big tool to strengthen, supply chain.
And as the last question, I'm asking each of our finalists, because we've got such a variety of different industries and jobs and backgrounds on our roster this year. So for you as an AM user and working in this industry, what is your biggest challenge that you're facing right now?
Well, personally, like it sometimes can be the adoption of AM in the company. Like in aerospace, it's not like the majority of parts are additive at all. It's just like it's they started to trickle in, right? So people are mostly used to other manufacturing process, and this one is newer, right? It is newer than other manufacturing processes. So for people to trust in it and see how, like, it's like you have to like switch something on in your brain to see like the possibilities of what you can get with additive, right? So getting people into that mindset, getting us like involved early in the process so that we can help, sometimes can be a little complicated, but I think we're getting better at that.
Well, Andrea, thank you so much for taking the time to chat to me today. And once again, congratulations on your nomination for this year and good luck.
Oh, thank you so much for having me.